Okay, you are welcome back to Introductory Mathematical Analysis A. Okay, we are still in chapter 8. And this time we are going to emphasize 8.7, which is the Bayes formula. 8.7 Bayes formula. Okay. Now recall in the last one we did recall that Bayes formula. Recall Bayes formula. Recall Bayes formula. Okay. Actually, in Bayes formula, we are dealing with a two-stage experiment. Two-stage experiment in which we know the outcome of the second stage. Two-stage experiment in which we know the outcome of the second stage. In which we know this outcome of the second stage, and we are interested in the probability that a particular outcome has occurred in the first stage. Okay, in the first stage. All right. Okay, so we are dealing with a two-stage experiment in which we know the outcome of the second stage, and we're interested in probability that a particular outcome has occurred in the first stage. Okay, recall in the last one we did that we have Fi given E, and then we said the probability of E given Fi multiplied by probability of Fi all over the sum of the Fi, E given Fi multiplied by probability of Fi, then plus the other side up to whatever value of n that we have, probability of E given Fn multiplied by probability of Fn. Okay, if n is 2, the last video we consider n to be 3 because we have component A, B, and C. So n is 3 there. If n is 2, that means we are going to have probability of F1 given E equals to probability of E given F1 multiplied by probability of F1 all over probability of E given F1 multiplied by probability of F1 plus probability of E given F2 multiplied by the probability of F2 if n is 2. Okay, we have this. So we have the first one to give us this, and then we will have the second one. We're just recalling what we did before. The second one to now give us probability of E given F2 multiplied by probability of F2 all over probability of E given F1. We can write the same thing. The same thing, they are the same. F1 multiplied by probability of F1 plus probability of E given F2 multiplied by probability of F2. So either you bring F2 first before F1 here at the denominator, it doesn't matter. It's the same to give you the same as this one. Is that okay? All right. That is what we did in the last video. But now, sometimes it is not into F1. We are not dealing with F1 or F2. We are dealing with a case where we have F and F prime. So sometimes we are dealing with those two cases and not on F1, F2 like in a company. But now we are dealing with having something, not having something. That means having a disease, not having a disease. I mentioned before that this Bayes formula is applicable and it has application in so many fields. So sometimes when we are dealing with disease, not disease, tested positive, tested negative, or not tested positive, we may want to use this. Okay, so if we are using that, that means we are now saying probability of F given E is equal to probability of E given F multiplied by probability of F all over probability of E given F multiplied by probability of F plus probability of E given not F. Now the other side of this is not F. Okay, the other side of it is not F. Here we are having F1, then the other side is F2. But here the other side is not F. Okay, so that will be that. Now the probability not F given E will become probability of E given not F multiplied by probability of not F all over the same thing we have at the denominator here. Probability of E given F multiplied by probability of F plus probability of E given not F multiplied by probability of not F. I mentioned that if you want to write this one first before this one is still fine, or you want to write this before this is still fine, you still get the same thing. You still, the order doesn't matter because it's addition that is here. All right, so sometimes this is what we need because we are dealing with having a disease, not having a disease. All right, let's illustrate that. So to illustrate this, let me call this example. So to illustrate this, it is believed that of a total population, our sample space, 8% have a disease. You see, have a disease. Imagine also that there is a new blood test for detecting the disease and that researchers have evaluated its effectiveness. Data from extensive testing show that the blood test is not perfect. Not only is it positive for only 95% of those who have the disease, it is also positive for 3% of those who do not have. Okay, suppose a person from the population is selected at random and given the blood test. If the result is positive, what is the probability that the person has the disease? Okay, in order to do this first, we need to write out our notation. So let D be having disease. Let D be having the disease. Okay, let D be having the disease. Okay, that means T will be tested positive or testing positive. Testing positive. Okay, so in other words, if D is those who have the disease, it means D prime is not having the disease. Not having the disease. Okay, and D prime, T prime rather. T prime rather is testing negative. Okay, or not testing positive. Testing negative. So we can now see we have D as having the disease, D complement not having the disease, T testing positive, T complement testing negative. All right, so let's read the question again and see. Don't forget, in conditional probability, you need to identify what is given and what you are looking for. Okay, read this. If the result is positive, so you are giving testing positive, what is the probability of the person has a disease? So you are looking for probability having disease. Testing positive, giving, having the disease is what we're looking for. So we are finding probability of D given T. That's what we are looking for. Please take note, this is not what we are looking for. This is probability of testing positive given disease. This is not what we are looking for. This is what we are looking for from this question. All right, so looking for this, what do we do? Then we write the equation for that, the formula for that. Probability of D given T. What is the Bayes formula for this? That is the probability of T given D multiplied by probability of D all over probability of T given D multiplied by probability of D plus, now the other side is not having the disease, probability of D given not multiplied by probability of D not, or D complement rather, D complement. Okay, all right, that is it. Now then we need to find the values of all these. Let's read the question again and find the values. From here we have the probability of D, probability of those who have the disease is 0.08. That means probability of D naught, those who doesn't have disease, will be 1 minus this, okay, which will give us 0.2. Okay, now again from here we have that not only is it positive for only 95% of those who have the disease, that is probability of testing positive given disease, that is this one, 0.95. all right, so now what do we need more? Okay, but it is also positive for 3% of those who do not have disease. So that means probability of T given D naught. Okay, probability of T given D naught is 0.03. Okay, you see, that's how to get your data out. All right, so now let's now use this value into our formula. Okay, T given D 0.95. So we have 0.95 multiplied by 0.8. I think that is correct. Let's check again. This is exactly this one, 0.95 multiplied by 0.08. Okay, plus, okay, T given T naught, T given D naught, 0.33, 0.03 multiplied by 0.92. Okay, I wrote that correct. Yeah, that's correct. Okay, now we find our values here. This multiplied by this gives us 0.076. This is same thing as 0.076. Then plus this one. Okay, this one is 0.0276. Okay, I hope that is correct. Okay, this will be 0.076 all over 0.1036. Okay, which will be giving us 0.7335. okay, this approximately to 2 decimal places. Okay, that is to 2 decimal places. Okay, that is fine, to 2 decimal places. So we have this. Okay, so that is the probability of having disease given testing positive. So we'll be giving out this. Okay, that's fine. So that is what they asked us to find. They said if the result is positive, what is the probability that the person has the disease? That's why. But if now I'm changing the question slightly, okay, let's assume that they said if the result is positive, what is the probability that the person does not have the disease, does not have the disease, That means we're going to be looking for the probability of D naught given T. I mean, we are going to be looking for the probability of not having disease given T. if that is what they said. Okay, let's find out the Bayes formula for that, and let's calculate that also. Okay, this will now give us probability of t given d prime multiplied by probability of d naught all over the same thing as the denominator here, the same thing as the denominator here. All right, the same thing as the denominator there, that is still giving d multiplied by probability of d plus t giving d naught multiplied by probability of d naught. Okay, we have all this already, so this is just exactly this. Okay, that is just exactly that. 0.03 multiplied by 0.92. Okay, all over. This is also exactly what is there, exactly what is there. So it's just 0 point this multiplied. So I'm just going to write only this one, 0.076 plus 0. Okay. So, but let me write that first so that you will not be confused. Plus 0.03 multiplied by 0.92. Okay, all right, so multiply that, we're going to get 0.02 0.0276. The whole of this is the same thing as the denominator there. Okay, as the denominator there, so it's the same thing as the denominator here. All right, now if we find this one now, then we're going to get approximately we're going to get 0.266. Okay, which is also approximately 0.27. All right, so if you are looking for the probability of not having the disease given testing positive, then we'll get this. Probability of having the disease given testing positive, also we have this. Now if you look at something, this is very important, take note. Probability of D given testing positive is equal to 1 minus probability of D not given testing positive. So if you look at this answer, if you say 1 minus 0.7673 rather, 1 minus 0.73, you will get this one. So this one is just 1 minus this other answer, 0.73. This is it. 1 minus 0.73 gives us this one. So that is why this formula, we write this like this. So the probability of D given T is equal to 1 minus probability of D naught given T. We can also write it the other way. Probability of D naught given T is equal to 1 minus probability of D given T. All right. So please take note of that. Please take note of that. I hope you understand. Please ensure that you understand. Thank you.